traveling out of the solar system. You pass Neptune, the farthest planet, and continue into the dark and cold space. But how do you know you have officially left the solar system? This question has no simple answer because the boundary of the solar system is not as clear as you might think. Our solar system can be said to be very vast, including 8 planets, 5 dwarf planets, hundreds of moons, millions of asteroids and comets, all orbit the Sun, and in many cases, they orbit each other at speeds of thousands of kilometers per hour. So where is the end of the solar system? The answer depends on the definitions of this planetary system. According to NASA, the solar system has up to 3 potential boundaries, which are the Kuiper belt consisting of rocky bodies beyond Neptune's orbit, then the Heliopause, which is the edge of the Sun's magnetic field, and the Oort Cloud, a region containing distant comets almost invisible from Earth. The Kuiper belt extends from 30 to 44 astronomical units from the Sun, where 1 astronomical unit equals the distance from Earth to the Sun, about 150 million kilometers. This area is filled with asteroids and dwarf planets. For example, Pluto was pushed out of the air solar system due to gravitational battles with the planets. Additionally, this belt is thought to be the origin of short-period comets like Halley's Comet. Although it is estimated that there are about 70,000 objects in the Kuiper belt with diameters larger than 100 kilometers, the total mass of the Kuiper belt is still very small, perhaps only equivalent to or slightly larger than Earth's mass. The outer boundary of the Kuiper belt is not arbitrarily defined. Instead, there seems to be a clear drop in the density of objects beyond the selected range. It is sometimes called the Kuiper Gap or Kuiper Cliff. The reason for these names remains a mystery. One possible explanation can be due to an Earth or Mars-sized object passing through the debris. Some astronomers believe the Kuiper belt should be considered the edge of the solar system, because it represents what should have been the edge of the Sun's protoplanetary disk, the disk of gas and dust that later developed into planets, moons, and asteroids. According to Dan Bray-Simca, a researcher at Los Alamos National Laboratory in New Mexico, USA, it defined narrowly that the solar system is only the Sun and the planets. Then the edge of the Kuiper belt could be considered the edge of the solar system. But some astronomers consider this definition too simplistic. It's not entirely accurate. Everything has shifted a lot, mostly outward since the planets formed. As explained by expert Mike Brown at the California Institute of Technology, the Kuiper belt does not contain everything in the solar system. In October 2023, the discovery of a series of new objects beyond the Kuiper belt suggested that there might be a second Kuiper belt even farther out. Some researchers argue that the uncertainty about the outer edge of this region makes it an unreliable boundary for the solar system. Heliopause. This is the outer edge of the heliosphere, influenced by the Sun's magnetic field. Here, the solar wind or the stream of charged particles emitted from the Sun becomes too weak to push back the radiation from other stars and cosmic entities in the galaxy. The exact location of the heliopause is not well known due to difficulties in direct observation. However, estimates based on data from the Voyager 1 and Voyager 2 spacecraft indicate that the heliopause is about 100 to 120 astronomical units from the Sun. Because the plasma inside the heliopause originates from the Sun, and the plasma outside the heliopause originates from interstellar space, some people consider the heliopause to be the boundary of the solar system, and the space outside the heliopause is often referred to as interstellar space. Another important factor of the heliopause is magnetic reconnection. Voyager is one of the key missions driving research on the interaction between the Sun and stars, and is also a factor in the definition of the heliopause. When flying beyond the heliopause, the Voyager spacecraft quickly detected changes in the type and intensity of particles and radiation directed toward them, indicating they had crossed a boundary. However, the heliosphere is not spherical but rather elongated, so using the heliopause to define the solar system would create a distorted system, contrary to the views of some planetary system researchers. The differences between current hypotheses about plasma and magnetic field structures near the heliopause require appropriate measurements that are currently unavailable on Voyager 1 and 2. The Oort Cloud. This is the farthest and widest potential boundary of the solar system, extending to over 100,000 astronomical units from the host sun. The Oort Cloud is divided into two main regions. The inner Oort Cloud is disc-shaped and the outer Oort Cloud is spherical. Both regions lie outside the heliosphere and in interstellar space. Those who define the solar system as everything gravitationally bound to the sun consider the edge of the Oort Cloud as the edge of the solar system. For some researchers, this is the ideal choice for the solar system's boundary, because theoretically, a planetary system includes all objects orbiting a star. However, other researchers argue that the Oort Cloud lies in interstellar space and is thus outside the solar system, even if gravitationally bound to the sun. Additionally, scientists are uncertain about the true endpoint of the Oort Cloud, making it a less reliable boundary than the Kuiper Belt. Among the three potential boundaries, the heliopause is most frequently used by researchers in NASA to define the solar system. The reason is that this location is the easiest to identify in particle properties on either side differs, but this does not mean everything outside the heliopause is an interstellar object. For example, the giant meteor Oumuamua passed through our solar system in 2017. Oumuamua is an object from a star system beyond our solar system. Though outside the heliopause, it was considered part of the solar system briefly during its passage. Additionally, there are other objects like brown dwarfs or rogue planets that may exist beyond the heliopause. They are not bound by the gravity of a specific star and can move freely in interstellar space. Therefore, defining the solar system's boundary relies not only on the heliopause but also on other factors like gravity, particle properties, and the presence of space objects. Defining the boundary of the solar system is a complex issue. The factors mentioned above are just some of the considerations. As scientists explore more about the solar system, its boundary may be defined more accurately. Subscribe to the Hidden_Realms channel to see more of the latest videos.